Everyone, if you can see me, if you can hear me, please write you in the chat box, everyone. Hi guys. Hello. Hi everyone. Hello. Guys, if you can see me, if you can hear me, अगर मेरी आवाज आ रही है, अगर मुझे देख पा रहे हो, सुन पा रहे हो, तो please write you in the chat box. Come on guys. Hello. Hello everyone. Hello. That's nice. That's nice. Okay, so we have Radhika, Ravi, Sairam, D Creative Channel, Mahesh, Aditya, Aparna, Ravi, Creative Shiva, Shri Ram, Ravi Shankar, Sanvi, Creative Channel Radhika, Venkat, Koti Lavanya, Telugu MNL. Very well. Good afternoon, guys. Good afternoon. Welcome to Vedantu's JEE channel. और आज का जो session है, what you can see, it is based on the doubts that you guys have asked related to gravitation. Okay. So this is targeted for everybody actually, whoever wants to send the doubts, but specifically for JEE 2020 students. Namaste everyone. Namaste. Welcome back. Welcome to the channel once again. Okay. So yep. Thank you everyone. I'm hoping that everybody is doing fine. And for those who do not know me, जो लोग मुझे नहीं जानते हैं, this is me, your Suri Sir, and more commonly I'm known as Mugambo on this channel. Why? Because when you will crack the examination of JEE, Mugambo push hoga. Yes, guys, very much. Okay. Okay. So people, if you are not aware, I'm sure you have already joined. If you have not, then for people who are preparing for JEE 2020, there is a crash course which we have started very recently on 27th of April. We have started this. You are getting 90 live classes by the best teachers with 3 sessions every day and happens on Monday to Saturday, all 6 days, with 20 comprehensive tests with assignments and detailed analysis being given to you. Okay. And yes, separate doubt solving by your teachers. You can watch replays and recordings and a lot more things. If you want, you can enroll by clicking on this link. Okay. So guys, if you want, you can go on Vedantu's app. There also you will find it, or you can go by clicking on this link which is available in the description of the video. But don't forget to use this coupon code, people. SMCC is the coupon code, because this coupon code will bring the crash course worth rupees 25,000 for just under 6,000 rupees for you. Okay. I hope the steps are clear to everyone. This is the link. Okay. Follow this link available in the description of the video. And step number 1, step number 2, step number 3, coupon code SMCC. Okay, guys. Fine. So everyone, a lot of informations, and yes, we'll come to problem solving. One more information: if you have not subscribed yet to the channel, do subscribe to the channel right now and press that bell icon as well, because a lot of activities happen on this channel every day and you want to be notified. Okay, awesome. So I have a lot of students live now. Let's go forward, guys, and solve the questions which are being asked by you as doubts on gravitation. So very first question is being asked by Mahir from Indore. I hope he is here live. He wants to understand escape velocity, orbital velocity, and variation of acceleration due to gravity due to height. So you know that on the surface here, say if I speak about point P, then the value of G is Gm by r square. But if I consider this point, say that is A, then at A, the gravitational field is G dash, and that value is Gm by r plus h square, which is written here. So acceleration due to gravity Gm by r plus h square. If this condition is satisfied, then you can take r outside, and the expression by using binomial expression is reduced to g times 1 plus 2 h by r. Okay, Mahir, this is basically how the gravitational field will decrease as you are going away, because if you are away from Earth, the weight of your body, the force by which Earth is pulling you, will also decrease. Okay, now let's speak about the orbital velocity. It is basically, it comes into discussion, orbital velocity, when you're speaking about a satellite motion. So if there is a satellite which is revolving around Earth, which is say in a orbit of radius r, mass of Earth is capital M, mass of the satellite is capital M, and say it is moving with an orbital velocity VO. So I'm interested in talking about this VO. So the force which is keeping this planet moving in the circular path is the gravitational force, which is GMM by small r square, or you can write this small r also as r plus h, totally up to you. Okay, so this small r is nothing but radius of Earth plus the height from the surface, and this should be equal to the centripetal force provided to the satellite, which is mvo square by r. So you can see that one r gets cancelled, m gets cancelled, and orbital velocities expression very simply comes out to be gm by small r in under root. You can replace small r also as r plus h. Totally your call. Okay. Remember, orbital velocity is basically the velocity which is required. Yep. Yes, Telugu MNL, for anything to move in a circle, centripetal force has to be acting on the body. That's why it is called necessary centripetal force. Now, when we speak about escape velocity, what is escape velocity? The minimum velocity that is required by any object to be thrown away from the Earth's surface or planet surface in order to escape the gravitational field of that planet. So we say that if the body is, say, right now here on the surface of the planet, say this point is A, and you eventually send it to a point B, which is at a distance infinite, that the body is not returned back to the Earth or to the planet. So we say that if the body is not pulled back by the planet, if the body reaches B, and even after reaching B, say the final velocity becomes zero, then you are talking about the minimum case. Okay, so the minimum velocity with which you should be throwing here is what you call as the escape velocity. So we say that the energy at A will remain equal to energy at B, and energy at A, by the way, is half mve square, the kinetic energy, and minus gm small m by capital R, the potential energy. At infinity, the potential kinetic energy will become zero, and because you have sent it to infinity, the potential energy will also become zero. This is on the surface, this is at infinity. Okay, that simply means what? Half mve square should be equal to g capital M small m by r. I cancel small m. V escape comes out to be 2gm by capital R. Okay, this is capital R. Okay, remember that. Okay, very nice. Now, this is Bhargav from Chennai. He wants to understand the concept of geostationary satellite. Bhargav, I hope you are watching this. You can see that there is a satellite which is revolving around Earth in such a way that its location is always above, say, in that case, somewhere above South America. So when Earth is rotating, that planet, the satellite is always maintaining its position above a particular country. So usually geostationary satellites are being sent by a particular country, and the whole objective of sending those satellites is to broadcast the information related to that country only. So we say that geostationary, if you go by the name also, geo is basically Earth, something related to Earth, and stationary is basically at rest. So a satellite which is at rest, because of the animation, the writing is coming like this, guys. So because of the concept of satellite being stationary, we name the satellite as geostationary. And for this to happen, can I say that the relative velocity, the relative angular velocity of the satellite and the Earth or the planet should be zero? And that is only possible when the angular velocity of the satellite is same as that of angular velocity of Earth, which simply means the time period of satellite should be equal to 24 hours. That's all. So if the time period of the satellite is equal to the time period of Earth's rotation about its own axis, then the satellite it will remain stationary, and obviously it has to have the same sense of rotation as Earth. I hope the point is clear. Okay. Next one. Now this is Shivam Tiwari from Surajpur, Chhattisgarh. He says, "Sir, I want to know what is the role of rotation and revolution in the gravity, and if there is no rotation, then how gravity gets affected." Okay. So Shivam, there is one more question which is being asked by Amar Singh from Ambedkar Nagar, UP. His question is also very similar to yours. He says that in gravitation, I face a problem in calculating small g only when we move towards pole or equator. Please give me a real feel of that. Although it's a simple chapter, please tell us the component of g also. So basically, what happens, guys? Say if the Earth is rotating about this axis, if this is the axis of rotation of Earth, then what happens if you are standing here? Say you are standing here, then what is happening? You are basically moving in a circle when the earth is rotating. And when you move in a circle, guys, you will obviously be feeling a centripetal or centrifugal force if you are in a non-inertial frame of reference. So what you see, this is basically a centrifugal force. This is basically a centrifugal force that your body is experiencing because of the rotation effect of earth. Okay. Now, because of the centrifugal force, the force with which earth actually wants to pull you is not actually the force which your body will feel, because of centrifugal force also acting on your body. So if I say that this is the circle in which your body is moving, okay, whose radius is r cos theta, then this is the centrifugal force. This is mg, which is acting towards the center of the earth, and this is, say, the weighing machine's reading n. And if this angle is theta, then you can say that this angle will also be theta. If I say that centrifugal force is f or f dash, then its component along this direction will be f dash cos theta. Yes or no? So along this radial direction, guys, along this radial direction, n plus f dash cos theta is basically your body's weight. And n is basically the reading of the weighing machine, which we say is recorded by the weighing machine, which we take as our weight. So what is f dash? You can see it here. That means what? It is n plus m omega square r cos theta, and cos theta become cos square theta equal to mg. Now I'll take this on the right hand side, and what you see here, guys, what you see, this is what the apparent weight of the body is going to be. This is basically your apparent weight, which is also understood as the reading of the weighing machine. Now, Shivam asked, what if there is no rotation? So if there will be no rotation, then this value will become 0. And if omega becomes 0, then the reading of the weighing machine will be equal to your actual weight. In that case, you will actually feel your weight everywhere on the planet. Means what? Usually your body's weight is minimum, or it is recorded minimum at pole. This is where your body weight will come out to be minimum by the reading of the weighing machine, and this is where it will come out to be maximum during rotation. But if rotation is not there, all these values of W will remain same. Okay. Next one. This is Anushka Paul asking question from Kolkata. Anushka says that, does the influence of gravity extend out forever? Yes, Anushka. If we write the gravitational field, say because of a point mass, which is given as g m by r square, then you can see that as r will increase, g will decrease, but only at r tending to infinity, g will tend to 0. Otherwise, its effect will remain everywhere till infinity, just like electric field. Okay. Next is weight of an object on the surface of the moon. Okay. Now this one is something that you should trivially know, that gravitational field of moon on the surface is 1 by 6th of gravitational field of Earth on the surface. So if we multiply this as mg moon, mass of your body, will be 1 by 6th of your body's weight on Earth. That means weight on moon will be weight on Earth by 6. That means your body's weight, whatever it is right now on Earth, it will become 1/6 of its value on moon. Okay, guys. Okay. Next one. Why gravitational potential is negative? This is Yuva Krishna from Krishnagiri. He says, why gravitational potential is negative. See, first of all, what is gravitational potential? It is basically the work done per unit mass. Which means what? this value is going to be equal to W, potential is going to be equal to W if m naught is equal to 1. So assume that you are bringing, say this is basically a body whose mass is capital M, and on surface of whose, say at point P, you want to calculate the value of gravitational potential. So what you are actually doing, from infinity, you are bringing an m naught mass till this point P. So from infinity till point P, whatever is the work you do, okay, say m naught is 1 kg. So in bringing this 1 kg body from infinity till point P, whatever work will be done by you, whatever energy you will be losing, will basically behave as the potential of this body at point P. Now, what we assume that at infinity the value of potential is zero. Okay, or you can say the value of potential energy is also zero. Potential is nothing but potential energy. It is zero at infinity, is what we assume, because there is no interaction gravitationally possible at an infinite separation. Now you know that if this is a mass capital M and this is a 1 kg mass, ideally they want to stay attracted, stay close to each other, because they are applying a gravitational force on each other. And there is a, very common sense point of view, you can understand this thought, that the stability is inversely proportional to the potential energy, right? So for the system to be stable, this point mass want to be at point P, which means what, potential energy will be minimum and potential will be minimum over here. V will be minimum. Okay. So that potential energy can be minimum and maximum stability could be there. And this is basically max stability. Now, if already at infinity the potential is zero and you are bringing them closer and you are increasing the value of stability, if you are increasing the stability, you have to further reduce the value of the potential. So what will you call a value which is less than zero? Can you tell me in the chat box? What will you call a value further lesser than zero? If already this value is zero, and when you are moving from infinity to point P, the value should reduce lesser than zero. What is a value lesser than zero? Yes, so Sujash told it very properly. This value is minimum, which simply means Vp is basically less than zero. I hope I have answered your question, Yuva. Because at infinity we have considered it zero, and on bringing a body closer you are further reducing the potential. The value possible further lesser than zero is only negative. That's why the expression of potential at P is written as minus Gm by R, or capital R, anything that you want. You can write it as small r for any general point as well. Okay guys. Now, next question that he asks is Earth treated as solid or hollow sphere? Yeah, that's a very obvious one. Earth is treated as a solid sphere. Next question that he asks is why Newton's law of gravitation is valid only for point mass. Not only just Newton's law of gravitation is valid for point mass, the Coulomb's law of electrostatics is also valid for point charges, for a reason that, you know, that how do we calculate the gravitational force? We write it as G m1 m2 by r square. So say you have an extended body which is not a point mass. It is lying between A to B, and say there is this point P where I have kept a mass m2 and this mass is m1. So if say the length of this body is L and this point is at a distance x, so if with respect to B, I will try to write the force, the value of R will come out to be X, but value of A will come out to be L plus X. So what you see here, what should I put the value of R as? For B, the value will be put as X. For A, the value will be put as L plus X. For some center point, it will be put as L by 2 plus X. So I hope that you are understanding this. Okay, getting my point, guys? Yuva? Because for a continuous body, you cannot directly apply it. You will have to break it down into small point masses, and then you will be able to apply the law of gravitation individually for each point mass dm. Okay, that's why it's not valid for an extended body and only valid for a point mass. Okay, Next one, what is gravitational self energy? Please explain in detail. Abhinandita Verma from Ajmer. So, Abhinandita, self energy is basically the amount of work which is done in making a body the way it is. Means what? Assume earlier there was no body here. This is basically a hollow sphere. Okay. And I want to find out in creating this hollow sphere how much gravitational energy must have been stored here, or how much amount of work must have been done by the external agent. So we say that small m masses, dm masses were brought here and arranged in a manner brick by brick so that this sphere was formed. So say at a given point, when say already m mass has been stored here, we want to basically change the mass of the sphere from 0 till capital M. Earlier there was no mass of the sphere, and then we want to eventually stop when the mass becomes capital M, any numerical value. So what you are doing basically, you are bringing say dm mass each time from infinity till this point P, and in doing that, every time when you are bringing more mass and accumulating it here, the potential of the sphere is rising. Yeah, under the value of potential is becoming minus g small m by capital R. That's what basically the potential at any given point is. But next mass that you will put, the potential will become m plus dm. Next, you will put m plus 2 dm, m plus 3 dm. That way, the numerical value of potential is changing. So, say at an intermediate step, when you have already brought some small m mass, you are further bringing a dm mass. So, this dm mass will be further easily attracted by the mass which is present there. So, in order to calculate the total amount of the gravitational potential energy of this sphere, its own self energy, which is basically the work done by the external agent, you will say it is nothing but the potential into dm. Yeah, why? Because potential is defined as work done per unit mass. So in this case, the work done that you are going to calculate is nothing but integral of v dm. Okay. Now, guys, the value of potential of the sphere at the moment is minus g small m by r. Just a minute. Huh? Okay, so I'll have to write again. So the radius is r, currently the mass is m, and this is the point P where you are bringing small masses dm from infinity till this distance r, and this is basically a hollow sphere whose self energy is what we are interested in calculating, whose mass will change from 0 to capital M. So the potential energy is the work which is done by the external agent, and that potential energy is what we call as the gravitational self energy, which is integral of V dm. Okay. So what is value of V? It is minus g. Right now, how much is the mass? Small m. What is the radius r? And how much mass you are bringing further? Dm. Okay. So minus g by r square comes out, and what you are effectively doing is integration of m dm. Okay. Yep. So integration of m dm is m square by 2. This will go from 0 to capital M. So finally, the self energy comes out to be minus g m square by 2. Sorry, this will not be r square, just r. Okay. This is basically what we understand as the self energy. The energy which is spent by the external agent in creating the body. Okay. Now, next one is Charan Alluri from Vijayawada, and he wants to understand the Kepler's law of planetary motion. These are very simple laws, actually, Charan. So there are three laws. The first one is called as law of orbits. In this, what it says that every planet revolves around Sun in an elliptical orbit. Okay, this elliptical orbit has two foci, and on one of the foci the sun is located. Okay, that's what simply a simple statement is, that all the planets are revolving around sun in an elliptical orbit with sun present at one of the foci. That's why it is called law of orbit. Second one is called law of areas. Okay. Now, what does law of area says? That whenever your planet is moving between any 2 points in its path, if between any 2 points, if it takes say some time delta t or t and covers the same or sweeps out the same area A, then we say that the aerial velocity swept out by the position vector of the planet, which is a by t, or you can say dA by dt. This aerial velocity remains constant, which basically leads to the concept of angular momentum of the planet being constant. Okay. So this is what the second law says. Third one is the more important law, called as law of period. What it says that the amount of time that is taken by the planet to revolve around the sun, which we call as the time period. Okay, just a minute, guys, so that you can see this. The third one, which I'm calling as law of period, don't worry, it will be visible to you. So the time period of rotation of the planet around the sun, square of that value, is proportional to cube of the length of semi-major axis. This is the semi-major axis A. So T square is proportional to A cube is what you call as the law of period, or the third one. I hope that you are aware about it. Yes, Aparna, this dA by dt is equal to L by 2m, where L is the angular momentum of the planet. Okay, Sharan, I hope you understood this. Now, next one. Now, this question is asked by Gokul from Coimbatore. He says that, sir, namaste. Yeah, namaste. A spaceship is sent to investigate a planet of mass capital M and radius r. So, this is basically a planet whose mass is capital M and the radius is capital R. And the spaceship has mass M. Okay, and initially is at a distance 5r from the planet also. So, what you do, you basically the spaceship fires an instrument package of speed v naught, and the package is of mass m, which is much smaller than the mass of spaceship. For the for what angle of theta the package must just grazes the surface of the planet. So basically, what is happening here? Say you want this package which has been thrown to just graze the planet like this, which is possible when it follows a trajectory like this. Okay, just a minute, guys. So this is how the package was released. Say it was released with a velocity VO at an angle theta, and this package is experiencing all the point of time the gravitational force towards the center of the planet, so that no torque is acting over it, and the angular momentum of the package remains conserved. Say by the time it reaches here, its velocity becomes V. Let me call this position as A and this position as B. So I'm saying that angular momentum of the package at A should be equal to angular momentum of the package at B, because at all the time the gravitational force is acting towards the center of the planet, making the angular momentum to be constant and torque to be zero. Okay, so if I write the angular momentum of this thing, the package at point A, it is m into v naught into 5r into sine theta, mvr sine theta, and at B it is going to become mvr and sine 90. Okay, so you can see that r and m looks like they are getting cancelled. Sine 90 is 1. So V value comes out to be 5 V naught sine theta. That's what its velocity is going to become when the package is reaching point B. Okay, and in this process, because the gravitational force is a conservative force, so the energy at A will also be equal to energy at B. So let's just write the energy here at A. The energy is kinetic energy and potential energy at A. Here we'll write kinetic energy at B and potential energy at B. So let's just go to the next slide and write it there. So kinetic energy in the beginning is half mvo square plus, in fact, I'm going to take it as minus. We know that y potential energy and potentials are minimum while written negative. So I'll have to write that value as negative, and that is minus G capital M small m by 5r. And when it reaches B, the kinetic energy becomes half mv square and potential energy becomes gmm by r by the time you have reached to point B. So let me do one thing, guys. Let me bring this VO here and this potential energy term here. That simply means I will have minus half m v square minus VO square equal to G capital M small m by r minus G capital M small m by 5r. Okay, so V value already is known, and M we can cancel here. So I have half V is, we found V as 5 V naught sine theta, so square value will be 25 V naught square sine square theta minus V naught square, and here it will become 4 by 5 G M by R. So this 2 goes there. Okay, so what do I have? 25 sine square theta minus 1 VO square is equal to 8 GM by 5R. Okay, guys. And if I bring this VO square also here, this will be V naught square here. So 25 sine square theta is equal to 8 GM by 5 V naught square R plus 1. Okay. And now what? I'll just write the value of sine square theta. So sine square theta is 1 by 25 in bracket 8 gm by 5 v naught square r plus 1, and that means sine theta. Okay. So sine theta will be 1 by 5, and in under root you will have 8 gm by 5 v square r plus 1. So now you can write theta as sine inverse. Okay, so from here you can find out the value of sine theta as sine inverse of the value that we got from it. Okay, Gokul, I hope you understood this. Nice. Okay, guys, moving on. Now this question is being asked by Deepak from Guntur, AP. He wants to understand the principle of superposition. So I have explained this n number of times though. Superposition principle is nothing. I'll have to give you a very simple understanding to it. It is nothing but polygon law of vector addition. Polygon law of vector addition is what we understand as the principle of superposition. Say the example, if I have to take, say there are four masses which are placed on the corners of a square of side length A, and you want to calculate the net gravitational force on each particle. So on this particle, point particle at B, C and D are applying the forces. If F2 is F and F1 is also going to be F, then F1 equal to F2 will be equal to G m1 m2 by r square. Let's call this force as F, and if I calculate F3, that value will be G m1 m2 by this distance, which is root 2a square. If you do that, it is 2a square, which simply means it is F by 2. Now you know that F1 and F2 will have their resultant in this direction only, which is under root of f1 square plus f2 square, or you can simply say it as f root 2. Yeah, so net force, I'm not basically getting into much of details of how we are finding. I'm just trying to give you an idea that what exactly polygon law of vector addition is. So you will say that their resultant f12's resultant and F3 resultant, F3 itself are in the same direction. So F12's resultant is F root 2 and F3 is already F by 2. So we get the value as F taken out 2 root 2 plus 1 by 2. So that simply means what? It is gm square by a square in bracket 2 root 2 plus 1 by 2. That's how we get the resultant force acting on any particle placed at the corner of a square. Okay. Okay, guys. Now, this is the question which is asked by Kushagra from Varanasi. He says that, say, if you have a solid sphere whose mass was m and radius is r, and a spherical portion of radius r by 2 has been removed from it. So this is radius r by 2 and this has been removed from it. And now you want to find out the gravitational potential at the center of this cavity. Means at this point you want to find out the value of the potential. Okay. So Kushagra, in order to solve this, what we will be doing fundamentally, we'll try to say that potential of the sphere is nothing but potential at point P is nothing but potential due to entire sphere without any cavity minus potential of the mass which was supposed to be at cavity. Okay, and this is how the expression of gravitational potential inside a sphere. This is how we write the potential. Okay, so now because of the sphere itself, V due to entire sphere, let's call it V1. In this value, minus G capital M by 2R cube, the value of radius is 3R square, as in radius is R, and X value from the center of the sphere, you are bringing it at a distance X, which is nothing but R by 2. So if I square it, it will be R square by 4. That means what? V1 is minus Gm by 2R cube. This looks like 12 minus 1, that is 11 R square by 4. So V1 looks like it's going to be minus 11. Just a second. So this looks like it's going to be minus 11 Gm by 8R. This is the potential if there was entirely a complete sphere was there, no cavity. Okay. Now, this is the first part. Okay. Now let's try to find out the mass of the cavity. How will I find the mass of the cavity? Say the density is mass of the total sphere upon its volume, which is 4 by 3 pi r cube. It should be equal to mass which has been removed as the cavity divided by its volume, which is 4 by 3 pi. Radius is r by 2. On cubing it, it will be r cube by 8. Okay. So what you see, r cube, 4 by 3 pi, 4 by 3 pi gets cancelled, and small m comes out to be m by 8. So that's the mass which you are removing from here. So the mass which has been removed from here is m by 8. And point P is basically the center of that sphere, which means what? The potential due to cavity mass, which I'm calling as V2, will be minus 3 by 2 times the potential of the sphere. Say its radius is small r. And what is small r? Small r is r by 2. This is for the cavity mass. Okay. So V2 is minus 3 by 2. Let's say mass is m dash. So G, this value of mass m dash is m by 8, radius is r by 2, so 2 and 2 get cancelled. The value of V2 comes out to be minus 3 by 8 Gm by capital R. Okay, this is the potential if cavity gets filled by the mass m by 8. Okay. So guys, the potential at P, as I said, is going to be V1 minus V2. You can see it from here. This is V1, this is V2. V1 was minus 11 by 8 Gm by R, minus 11 by 8 Gm by R. Venkat, you want to know how to ask the doubts? Wait till the end of the session. I'll tell you how can you ask the doubts. And this becomes plus 3gm by 8r. So you can see that denominator is same. So minus 11 plus 3 is going to be minus 8gm by 8r. 8 and 8 get cancelled. Final answer is minus gm by r. That's basically the potential at the point P, at that point P here. Okay. Kushagra, remember, potential is nothing but work done. It's a scalar quantity. Okay, so that's our answer. Okay, now this one, this is a question which is asked by Atharva from Kota. He says that a bullet is fired vertically upward with velocity v from the surface of a spherical planet. When it reaches its maximum height, its acceleration due to gravity is one-fourth of its value from the one-fourth of the value of the surface of the planet. So if the escape velocity is v by v into root n, then n ka value is what we have to find out. So according to his information, g dash is g by 4. And what is g dash? I'll write it as gm by r plus h square, which is gm by r square, and the value is one-fourth of it. So gm and then gm cancel. I see that r plus h is going to be 2r, or h is equal to r. So you have to take the body at a height of r in order to satisfy the value g dash equal to g by 4. Okay, now when you have taken the body here, the body stops. When you are throwing something upward at a height h, small h, the body is going to stop. So I say that the energy of the body initially should be equal to energy of the body or the system finally. So initially you are throwing the body with a velocity v, so kinetic energy is half mv square. It has potential energy with earth, that is minus g mm by r, and when it reaches a height h equal to r, the potential energy becomes minus gmm by r plus h, which is 2r, and kinetic energy obviously becomes 0. Okay, so you bring this thing here, so you have half mv square equal to g capital M small m by r minus g capital M small m by 2r, which makes it gmm by 2r. Okay, so you can see that m and m get cancelled, 2 and 2 get cancelled, v comes out to be under root of gm by r. Okay, and what is escape velocity? Escape velocity, in the beginning only I did the derivation, is under root of 2gm by r, which is basically root 2 times the value of v. That means if you compare it here, the value of n is 2. That's our answer. Okay, Atharva? Okay, recoil velocity will be very less. Arhit, the value of recoil velocity will be very less because the body that you throw upward has very less mass. Okay, no Santosh, no recoil velocity in this case because masses are not comparable. You are throwing a bullet. Bullet ka mass and earth ka mass is hugely different. Yes, this condition is practically possible if you have a bullet which can throw a body to 6400 kilometers. If you can have a gun which can throw a bullet to that high. Okay, guys. Now somebody asked me how can I ask the doubts. So, guys, we create a Google form every time when the doubt sessions are kept, and the announcement of that is done on a Telegram channel. So if you want to ask the doubts related to a chapter, we make those announcements on the Telegram group. So that is why it is advisable to come on the Telegram group of ours, where you will be getting all the assignments, all the notes, and the daily updates. These daily updates include the the information of asking the doubt, the link to ask the doubts also, where you will be mentioning your doubts. Okay, those dates are being given on that information only. For that you have to be on the Telegram group. Okay, so all you have to do, guys, follow the link which is available in the description of this video. नीचे एक description box होता है, वहाँ पे you will find the link of this Telegram group. Do come, and you will get to know that it is very helpful. Okay, so guys, I hope you guys enjoyed today's session. बहुत अच्छे से हम लोगों ने gravitation cover किया. If you enjoyed, then do like this video, share with your friends as well, and more importantly, subscribe to the channel, press that bell icon, okay, so that you are notified about everything which is happening on this channel. Cool guys, so even during this lockdown, the only single motto that we are following, that learning won't stop. Okay guys, so I'll see you again next time. Till then, keep studying, keep sending your doubts, and keep smiling. More importantly, stay inside, stay safe. Bye bye guys. Bye bye. Take care.